Hi, welcome to another Level 3 differentiation video. In this video, we talk kinematics. Kinematics is the study of motion. Use the following notation. S is displacement, which is a word for distance. V is velocity. A is acceleration. And T is time. We developed this little graph when we developed the Level 2 calculus. And to differentiate displacement, we get velocity. When we differentiate velocity, we get acceleration. And when we anti-differentiate acceleration, we're back to velocity. And anti-differentiating velocity, we're back to displacement. It's important to note in kinematics, direction is important for all of those. So if we're moving up or to the right, we're going in a positive direction. If we're moving left or down, we're going in a negative direction. All right, let's get into our example with 5 different parts. A scientist is monitoring alpha particles and has discovered the displacement in nanometers of a particle after t milliseconds is based on a sine function. S is equal to 2 sine bracket 3t. So part A, how far from the origin is the particle at 3.5 milliseconds? Well, we're talking how far, so we're talking distance. So all we need to do is substitute 3.5 into our displacement formula to get 2 times sine bracket 3 times 3.5, and we get negative 1.759 nanometers rounded to 4 significant figures. The negative means we are moving to the left of the origin, and we are 1.759 nanometers to the left. All right, part B, how far has the particle traveled between the 5th and 6th millisecond? Well, this is a typical kind of question. Again, we're talking how far, so it's distance. So we're just going to substitute 5 and 6 into the displacement formula to get our 2 distances, one at 5 seconds and one at 6 seconds. And then we're going to work out the difference between them by subtracting them to work out how far we've traveled between that second. We get a total distance of 2.803 nanometers. Now, if you're not quite sure what's going on, at 5 seconds we are 1.301 nanometers. At 6 seconds, we've moved to negative 1.502 nanometers, so we've moved a distance of 2.803 nanometers. Right, let's move on. What's the velocity of the particle at 7 milliseconds? Well, now we're talking velocity, so we need to differentiate the displacement function to get velocity. So sine differentiates to cosine. We leave the 3t alone, and don't forget to times by the 3 because it's a composite function, so the 3 is the u dash. Right, this simplifies down to 6 cosine bracket 3t. And we want to know the velocity at 7 milliseconds, so we substitute 7 into the velocity function to get negative 3.286 nanometers per millisecond. Now the negative, once again, means we're moving in a negative direction. Right, part D, what's the initial acceleration of the particle? Well, we've got a velocity function we worked out in the last part, so we once again have to differentiate to get the acceleration function. Now, cosine differentiates to negative sine, so that's why we get negative 6 sine bracket 3t, and once again it's composite, so please remember to multiply by u dash, which is 3. So our acceleration function becomes negative 18 sine bracket 3t. Now the word initial means at the start, at time 0. So all we need to do is substitute 0 into our acceleration function and get an acceleration of 0 at the start. Right, finally our last part, find the first time the particle is travelling at a maximum velocity. Well, we know our velocity function, we've worked that out earlier. If we want to know the maximum velocity, we need a gradient of velocity, and the gradient of the velocity is the acceleration. So we need to put the acceleration equal to 0, because to find the maximum, the gradient has to be 0. And we need to solve this, and hopefully you've done this in the trig section to get a time of 1.571 milliseconds. Great, thanks for watching.